In this lesson, we're going to be talking about the types of solutions you can get when you divide decimals. The first type we're going to talk about is terminating. Now, terminating decimals are what we've actually been working with already. It is a decimal that ends. What I mean by that is that as you're dividing, you will end up with 0 at the bottom of your long division problem. So a good example of a decimal that ends is if we do 3 24 hundredths divided by 5. So let's do this one together. We put the 3 24 hundredths inside, and we know the decimal goes straight up in our answer, and we put the 5 on the outside. Now 5 does not go into 3, so we can either jump straight to the 32, or we can show that it does not go into 3. 0 times 5 is 0. Subtract to get 3, and then bring down the 2. 5 goes into 32 6 times. 6 times 5 is 30. Subtract, you get 2. Bring down the 4. 5 goes into 24 4 times. That's 20. Subtract, you get 4. Now, we've already been talking about this. Right now, it looks like we still have a remainder, but we know that you can add zeros to the end of any decimal, and it doesn't change the value of the decimal. So I'm going to add a 0 to the end of the number I'm dividing into. Bring that 0 down next to the 4. Now I have 5 goes into 40 8 times. 8 times 5 is 40. Subtract, and I get 0. So it ends. It ends at 0 at the end of my long division problem. So I know that 3 24 hundredths divided by 5 is 648 thousandths. And you are going to be required to write what type of decimal it is in your homework as well. So at this point, because it ended, you will tell us that it is a terminating decimal. The second type of answer that you can get is a repeating decimal. A repeating decimal has one or more digits that repeat forever. So what's going to happen when you're doing this division is it's going to form a pattern in your long division problem, and you're going to see that the same number is repeating over and over again. So let's do 15 8 hundredths divided by 6. We're going to put the 15 8 hundredths on the inside and the 6 on the outside. My decimal goes straight up in my answer. 6 does not go into 1, so I'm going to go straight to the 15. 6 goes into 15 2 times. That is 12. I subtract and I get 3. I bring down the 0. 6 goes into 35 times. That's 30. I get 0. I don't subtract, I bring down the 8. 6 goes into 8 one time. That is 6. Subtract, I get 2. So I still have a remainder. Nothing's happened yet. It hasn't either terminated or it hasn't formed a pattern yet. So you have to keep adding zeros until it either terminates or forms a pattern. So if I add a 0, bring that down. 6 goes into 20 3 times. 3 times 6 is 18. Subtract, I get 2. I add a 0. Bring that down. 6 goes into 20 3 times. That's 18. So do you see what's going to happen here? You're going to subtract to get 2. Bring down the 0. You're going to get another 3. So it's just going to be 20, 18, 2. 20, 18, 2. 20, 18, 2. It's going to keep going on and on forever. So the 3 in the thousandths place is repeating over and over again. So here's how you're going to write that answer. You have 2 and 513. Now notice I didn't write that second 3 because it's not 3, 3 that's repeating. It is 1, 3 that repeats over and over again. And I'm going to draw a line over just that 3 because that's the number that's repeating. So this right here, that is your repeating symbol. That is what you're going to put over the number that goes on and on forever. Now, sometimes it's going to be more than one number. You need to remember that. It could be 0.27272727. You have to remember it's the 2 and the 7 that are repeating, and then you'd put the line over both of those numbers. Okay, so again, once you've solved your problem, then you also have to tell us that this is a repeating. So you'll have to write that word as well when you're doing your homework today. Okay, so we are going to do 4 more problems. I'm going to give you the problem. You're going to stop and do it, and then come back and check that your answer is right. Let's start with example number 1. I would like you to try 218 3/10 divided by 3. All right, try it out. See how you do. Okay, now as we go over this, I would like you to follow along with the problem that you did. And if you made a mistake somewhere, you know you need to fix it so your answer is right. So I put 218 3/10 inside, and I put my decimal straight up in my answer. And I am dividing by 3. All right, 3 does not go into 2. 3 does not go into 1. 3 goes into 21, not 1. I'm sorry. 3 goes into 21 7 times. That is 21. Subtract, I get 0. Bring down the 8. 3 goes into 8 2 times. That's 6. Subtract, I get 2. Bring down the 3. 3 goes into 23 7 times. That's 21. Subtract, I get 2. Bring down the 0. 3 goes into 20 6 times. That's 18. Subtract, I get 2. Add another 0. And I see it's happening again. 3 goes into 20 6 times. That's 18. And I see that I'm going to get 20, 18, 20, 18. So I know that that 6 is repeating. So your final answer should look like this. It should say 72 76/100 with just the 7 repeating, and then you should have the word repeating written next to it. This is what I'm looking for when you solve the problem today. Okay, for example 2, let's try 45 divided by 8. Go ahead, try it out. See you in a minute. Okay, 45 divided by 8. 45 goes inside, 8 goes outside. 8 does not go into 4, so I don't need that. 8 goes into 45 5 times. That's 40. Subtract, I get 5. Now, we've looked at this before. We have to remember that we add a decimal in our problem now because there wasn't one there, but we know it's at the end of the number. So we add a decimal at the end, and then we can start adding our zeros. So 8 goes into 50 6 times. 6 times 8 is 48. Subtract, I get 2. Keep adding until it terminates or repeats. So 8 goes into 22 times. That's 16. Subtract, you get 4. Add another 0, bring that down. 8 goes into 45 times. That's 40. And I get 0. So there's no more that I can do. So my answer is 5 625 thousandths. And then you have to write that it is terminating because it ends. Again, your final answers should look like this. Your full answer with the word showing what it is. Okay, 2 more. And then you're ready to keep going. Work on your homework. Let's look at example 3. For example 3, I would like you to solve 71 hundredths divided by 4. All right, try it out. See you in a second. All right, the 71 hundredths goes inside, and the 4 goes outside. I bring my decimal straight up in my answer. 4 goes into 7 one time. Now remember, if that was, say, a 3, you would have to show the 0 there for place value. You remember that after the decimal, you have to add those zeros to show place value. So 1 times 4 is 4. Subtract, I get 3, bring down the 1. 4 goes into 31 7 times. That's 28. Subtract, you get 3. Bring down the 0. 4 goes into 30 7 times again. 28. Subtract, you get 2. So I add another 0 and bring that down. And I have 4 into 20, which is 5, which is 20. And now I'm at 0. So it did terminate. So I have 1,775 10,000ths, and it is terminating. Remember, if you don't have the right answer, you're supposed to be erasing what you have and putting in and making sure your notes have the correct answer. All right, last one. I would like you to do 40 and 6/10 divided by 9. All right, try it out. See you in a second. All right, inside you have your 40 and 6/10. My decimal goes straight up, and outside you have your 9. 9 does not go into 4, but it does go into 40 4 times. 9 times 4 is 36. Subtract, I get 4. I bring down the 6. 9 goes into 46 5 times. That's 45. Subtract, I get 1. Bring down the 0. 9 goes into 9 goes into 10 one time. That's 9. Subtract, I get 1. Add another 0, bring down that 0. 9 goes into 10 one time. That's 9. Subtract, I get 1. So you see what's going to happen? 10, 9, subtract to get 1. 10, 9, subtract to get 1. So it is 4 and 51 hundredths with just the 1 repeating. Remember, you don't write both ones because it's not repeating 11. It's the 1 that is repeating over and over again. Okay, so that's your final answer. And you're going to try this out on your own now. Good luck.